Okay, so today we're going to talk about two vulnerabilities. The first one, well, both of these vulnerabilities are hopefully squashed off the internet already, but I think it's helpful to look at these things because you'll see the artifacts of how they got squashed throughout. So the amount of exercises I'm going to have you do on these two things is very minimal. It's just to get you the idea of what happened back in the day, and why these headers now in HTTP exist to wipe this stuff out. So cross-site request forgery, this used to be in the top 10 of OWASP, and because we've done such an effective job of getting rid of this, this is extremely rare. The other one that I'm going to talk about is ClickJacking, and that's another one that we, once it became a problem, they developed some headers and then basically shut that out as a vector of compromise. Okay, so what is cross-site request forgery? So before we talked about cross-site scripting, and the idea is to trick your victim browser into executing some code, some JavaScript code, unbeknownst to that user. CSRF, or CSRF as it's sometimes called, is to trick your browser not to execute code, but to actually make a request unbeknownst to that user that the user might not have intended. Okay? So what is the pattern? The problem is that often web browsers will automatically include the authentication credentials on any request going to a particular domain, even if that request isn't even if that user isn't directly using the site. So an example of this is sending the session cookie or the basic authentication header. And if the request is coming from another site, so say you're on a third-party site, and in that third-party site they have some embedded content to point to like chase.com or wellsfargo.com, the web browser is programmed to send your authentication cookie along with that request for that embedded content. Okay? So here is an example. This is a screenshot of Wells Fargo's site back in the day, a site with this vulnerability. And what happens is the attacker finds a function on this vulnerable site that he wants to trick the victim into hitting while authenticated. The victim isn't intentionally going to try and hit this link. The adversary wants to trick the victim into accessing that. So then, within the attacker's malicious website, the attacker places this hidden image tag. And as part of the image tag in HTML, you specify a target. And so in this case, the attacker specifies a target to that authenticated function that the attacker wants the victim to visit. And then while the victim is logged into the bank site, if the victim goes to the attacker site, then when the victim tries to retrieve the embedded content of the attacker's site, the victim will hit the authenticated vulnerable site with that request that they didn't want. They might not have wanted. Okay, so that is the rest of the workflow. And then when the victim gets this, this embedded content, then the GET request with the user's credentials are sent to this site, and then the vulnerable site sees a legitimate request by the victim and then performs whatever action is associated with that request. Any questions about the vulnerability and how this is going to work? Okay, so here's an example, bankpal.com. And so the adversary, the attacker, is going to host on his or her site this malicious HTML, and you can see the embedded image tag is pointing to the bank. And the bank site has this route that says transfer funds from one account to another, and so this is the attacker account, maybe this is the victim account, and then if the victim visits this page, the victim will hit this URL. So it only works if the victim is logged into bankpal.com, right? Because the bank is going to say, is this actually coming from the victim? And so if the victim has authenticated, then yes, this is actually coming from the victim. It's coming from the victim's browser. And obviously, the browser is programmed to send the authentication cookie when it accesses that link. Okay, so this assumes that the request is done with a GET. So when you do an image source and you specify a URL, it's using HTTP, and it's using the GET method of HTTP to do that retrieval. Most important functions aren't implemented with a GET, right? They're implemented with a POST. So another way of doing this kind of attack is that if the transfers are done with a POST, you can send the victim an enticing email like this one. Say, hey, this is coming from bankpal.com. Looks like you had a suspicious login. To resolve this issue, why don't you click on this login button? And this login button will have the bankpal.com URL associated with it, because what has happened is that the adversary, as part of implementing this login button, has done this. The actual form action for this login button points to the original site, bankpal.com/transfer, and then these hidden post fields are used to basically set up the transfer to the attacker account. Okay? And then when the victim clicks on that, that's definitely going to be using the post to do the transfer, and if the victim has authenticated, this will hit the authentication route. We'll log in, the victim will click on this, will log in, and then this will be posted from the victim. Okay. And get that transfer to happen. So this is not a good thing, right? So if you don't want to bother having a victim actually click on that button, this can also be done using JavaScript. So if you, again, host a malicious page, the victim is logged into bankpal.com, visits the adversary's page, and the adversary's page, on loading that page, will execute the JavaScript. And what this JavaScript will do is it'll do a document form submit of the exact same form submission that they had on the previous one. Okay? So that also will do the same thing. This is the pattern that's going to be used in the Portswigger labs to test whether or not you have successfully done a CSRF attack. Okay, so what do you do when you have a CSRF vulnerable site? Some of the things that you might see happening would be to initiate transactions that the user might not want, like transferring funds, closing the account. Another thing is to access any sensitive data on that account, or to change the account details. If you want to hijack someone's bank account, then maybe you'll change the email address on the account, or the mailing address would be another one that you could do. Okay, so let's talk about prevention. And this is very timely. Google timed this very well for us. This was deployed 2 days ago on Chrome. It was announced last year, but because I think Google knew that we were going to cover CSRF in this class, they released it for us on Tuesday. And so I was able to put this slide. It was very considerate of them. So yeah, it arrives today, and that today was on Tuesday. And it's got this site-breaking cookie change. Why would Google break cookies? Well, they're breaking cookies just to get, well, one of the reasons they're breaking cookies is for this. Another one is to make things a little bit more private, to support protecting user privacy. So these are the two reasons. The mechanism is called same-site cookies. So what are these things? In order to talk about same-site cookies, I'll have to talk about kinds of cookies. The kinds of cookies that are typical are the ones that are called first-party cookies, and these are same-site cookies. This means it's a cookie that the site that you're visiting, a.com, creates for you, and when you it's intended for use when you are directly interacting with the a.com web service. And so this is considered first-party access to the cookie. Because you're on a.com, you're using the a.com cookie directly on that site. So there's no problem with that. That should always be allowed, otherwise cookies are completely broken. The other kind of cookie is a third-party cookie, and this is called a cross-site cookie. This is created and used by domains other than the one you are visiting directly. So you are sitting here visiting, so in this case, you're visiting b.com, and you have b.com's cookie, and then within b.com, if you have access, if b.com points to content on a.com, then it's going to use the a.com cookie to access some content. So you're on a different site, but you're using a.com's cookie as part of the retrieval of embedded content. So this is called a third-party cookie. Third-party cookies are very valuable. They're often used for cross-site tracking and ad serving. So all of your ad networks, all of your social media networks that want to track all of the different places that you're web browsing, e-commerce, like if you have Amazon and all of a sudden you see Amazon ads for things that you just looked up on Amazon, they're doing this because they need to track you, or they're doing this with a third-party cookie that's tracking you across the different properties that you're visiting. Okay, so this is the way it works. You have an ad network, and this ad network has, so let's say this is Google's AdWords. Well, AdWords and AdSense, so maybe all of these different colored sites, so the orange, the purple, and the green, they're basically subscribing to this ad network. And then the banner ads at the top of these pages are being hosted by, let's say, Google. And then that is the tracking cookie, the green, that whenever you hit any of these sites, because you're retrieving the embedded ad from somewhere else, basically the ad network, you're going to access this as a third-party cookie. So you're going to retrieve the content of the green using the green cookie. Okay, and that's how the tracking is done across a bunch of sites. So if you're a social media company, that embedded Facebook icon that's hosted by Facebook, that is also going to do the same thing, track your usage using the Facebook cookie. So this is something that a lot of the privacy advocates are like, maybe that's not a good thing. We have to be able to control that kind of information flow over the internet, is the idea. Okay, so what is this same site cookie attribute that just got introduced? It's basically intended to specify whether or not that cookie can be used outside of its own site. Whether or not it is required for that cookie to be used while you're on that first-party site, or whether you can allow third-party access to that cookie. And the syntax of same-site cookies is exactly the same as the HTTP-only cookie and the secure cookie, where it's only being sent over HTTPS. So here's an example of a header, set cookie. You have some kind of cookie value here, and then you have this field that says same site is equal to strict. So what does that mean? Strict means that you can own, this is basically the jargon for a first-party use only. You must be on the site that this cookie is associated with in order for me to send this particular cookie. So that's what the strict is. What does same site mean? So is it an identical match between the URL and what the cookie has as its domain? As it turns out, it's fuzzy because every site has different notions of what a same site is. So here's an example where maybe the people who own web.dev, maybe they want all of their subdomains to be considered the same site. They want to share all of the cookies amongst all of their domains. Whereas something like github.io, where each one of these subdomains is owned by a different user, potentially, they want these things to be different. And so there is this notion of a public suffix list where you publicly announce what are things that are considered same site for the cookies, what are things that are considered different. So that's what we have to define what a site is, in order to be able to understand what a same site is. And so that's the definition of a site, and it's done via this public list. Yes? Yeah, so this is where you have to bind the name to same site. So if someone has done an exact copy of your site, the domains don't match, and then the cookie won't be shared. That's correct. Yeah, that's one of the ideas. Okay, so same site strict says only use this cookie when the domain in that URL bar is the same as the cookie's domain. So I know as the browser what URL I'm rendering. I will only send that strict cookie when that URL bar matches it. So you want this for sites like banking, right? If you're going to transfer some funds, I don't want you to be transferring funds from a third-party site, right? I'm only going to send that authorization cookie if you're actually on my page, navigating my buttons. Okay, so then in that previous bankpal.com case, if you were given that email that had login and it was trying to do a transfer, because of the strict setting, that click won't send that cookie, right? That click, because it's coming from outside of bankpal.com, is going to say, don't send that cookie on that initial click. Now, when you click that, it will get you onto bankpal.com's page, and then you'll basically be in that bankpal.com's authentication flow, and then you'll be clicking on things through that interface. So it's harder to trick a user. Okay, and you'll get this, this kind of error when in your console if you're accessing the same site, the strict cookie in a third-party manner. Okay, so another setting for this is lax. And so lax, you always send a cookie when you're on the first-party site, but lax allows you to send the cookie whenever the site is being accessed via a top-level navigation, so like an href, an embedded href, but only if that href is using a safe HTTP method, basically a GET. And so this allows you to say, okay, I do want the cookie to be sent, but it can't be done on a post. And typically the really sensitive functions are done with a post, whereas things that are less sensitive, like preferences, are done with GETs. Accessing those with GETs that are fine. So you'd send a cookie, but maybe not the post. And so this lax setting allows you to, so when you get that email that says, hey, log in here, that would be allowed, right? So clicking this link will actually send that cookie, but because it's not allowing the post, so I'm sorry, that login button on that email, because it's a post, that would be denied. But if it were a GET, if you were getting an image off of bankpal.com, that would be allowed. You would send the cookie with that. So you would send the cookie on the GET, you wouldn't send the cookie on the post with this setting. This is now Chrome's new default. If you do not set the same site header on a cookie, it just assumes you're going to do this. So it restricts all the cookie sendings on posts on third-party sites. Okay, this is the third setting. Same site as none, but at least send it over a secure channel. So allow this, basically this is full cross-domain usage of cookies. And so things like site analytics services, like Google Analytics, things like ad tracking, you would want to make sure this is your policy because you want ultimate sharing across all of these usages. And so this has been the current default, right? It's been the Wild West up until Tuesday. And so this is the thing that's going away. And this is why those headlines are like, oh, your stuff might break, because now the default is this thing in the middle. Okay. So a lot of people are now setting their cookie attributes to this. So you'll see that. Are there questions about these policies? Yeah.
I've noticed that a lot of sites have alerts that pop up that detect if you are moving to a different site. Like, you have to do that. And so that, like, if you don't want to go to a different site, then you can be like, no, cancel, stay on that site.
Yeah, and that, so we talked a little bit about the sites that are notifying you when you're going to a different site so that you're not tricked into thinking that that site is the same site you've been accessing. And this is especially important for the redirects and the forwards because that is one way of tricking a user into bouncing off of a legitimate site and then landing on a malicious one without them knowing if the malicious one looks like the original legitimate one. So typically, if you are a legitimate website and you do implement redirects and forwards, you would put that window up that says, hey, look, you know, you're redirecting somewhere else as a user queue. Yeah. Okay. All right, so this is a picture of what these policies look like. So the none setting means I can share this cookie whenever I'm on this orange page and I need access to the green cookie because I have a green embedded object. That is the current thing that's allowed. Lax says if I am clicking on a link that will eventually get me to that page, the top level page, as long as it's a get, that initial click, I'll always send the cookie. Doesn't matter where this link shows up on. It could be on the malicious person's site. But as long as it's a get, even when I click on that link, it'll send the cookie. And then finally, strict means no, the request must come from a page hosted in green in order for me to send that green cookie. So typically, the really sensitive authorization cookies for doing transfers are set using strict. And so this allows you to do one kind of cookie for tracking and preferences, and another kind of cookie to do like financial transactions, which is sort of the difference between a lax one and a strict one. Okay, another countermeasure is these CSRF tokens, and we've referred to this a couple of times already. The idea of these things is to add a secret token onto the origin page that is different from access to access. This is basically embedding a cookie into every page that you deliver to your users. And then when the user tries to submit a request back onto that page, that thing is echoed back, and the server is like, oh, yeah, that was a nonce or a token that I issued before. I'm going to allow that access. And in that way, the adversary, because the adversary is trying to trick a user into automatically accessing that sensitive page, unless that user has somehow leaked the CSRF token, there's no way for the adversary to include a valid CSRF token on that request to trick the user into doing that transaction. So these tokens, they should be cryptographically secure. They should not be predictable, otherwise the whole mechanism is broken. There were times that people were putting the CSRF token in, but it was always set to 0. So it's like, okay, if I know, I mean, it's there, but if I know that it's 0 all the time, it's like it might as well not be there. The example that you might find is in the input field. You'll see whenever there's a form submission, you'll see that there's a hidden field, and the hidden field might have either a name of token or a hidden field might have CSRF. So on the, I think it's the Portswigger site, the name is called CSRF. And that's basically what it is, and that thing will get transparently echoed back when you hit the submit on a subsequent request. Okay, so with CSRF tokens, you have to ensure that this token is never exposed. So for example, if you're putting the token, if you're submitting your forms via GET, and the token field, even though it's hidden, is still a parameter in your form, and you're retrieving the form over a GET, that token is going to show up in the URL bar, right? And then it's going to be in the refer of the malicious, like if you visit the malicious site from there, it's going to be in the refer URL for the victim to pull out. So that token should never be sent in the clear, and in particular in the URL. Okay. You also have to make sure your site doesn't have any cross-site scripting vulnerabilities. Just like those cross-site scripting attacks were trying to get the cookie, the cross-site scripting attack could also get your CSRF token and then be able to try and trick you into using that CSRF token to withdraw money. Okay. It's recommended that you have a token per function so that if the adversary figures out one token, they can only have access to one function on your server rather than the entire list of them. So hashing the function name on the back end along with the client session ID and a secret, or to generate the secret is something that you could do. Other methods is to only use HTTP GETs for most of for safe methods at least. Methods that don't have persistent side effects on the server, and always force the post with tokens for things that have side effects. So this is a web development sort of when you're a website design pattern that you would want to enforce. Okay. Requiring secondary authentication for every sensitive function. So you'll see this sometimes on bank sites. They'll ask you to log in again and reissue you a cookie, an authorization cookie in band. That's almost like the same thing as a strict cookie. You're forcing a reauth every time you hit a transfer funds, for example. And then expiring the cookies very quickly, so that if you are on Wells Fargo doing some sensitive thing and then all of a sudden you switch tabs to some other malicious site, that cookie in Wells Fargo is going to expire within perhaps 5 minutes to force a re-login if you're hitting the CSRF vulnerability on the malicious one. Okay, so that's CSRF. Are there questions about that before I do the second one? Okay, so the second thing I'm going to talk about is what's commonly referred to as ClickJacking. But you'll see these other two descriptions of it. One is Unsolicited Framing, and the other one is User Interface Redress. So these are fancy technical terms for these three things are all the same. It's a very simple vulnerability or exploit. The idea is that you trick a user to visit a malicious website. So this is the URL of the malicious website, and the malicious website has content that's very particular. It has, first of all, a malicious iframe. So we talked about iframes being able to pull up the content of a site, whatever that site is. So in this case, the iframe is pointing to some sensitive site. And the sensitive site is here in this little frame below. And when you bring up an iframe, you can place the iframe anywhere in the browser. Any dimensions, any place in the window. And what the adversary is going to do is it's going to load up this iframe and then make it transparent. I'm going to make it invisible. And this is the magic of CSS, if you're in the full stack course. CSS is like, do you want to make that thing visible? I'm like, no, I want to make that invisible. I have no idea why that's allowed. There must be a reason. I'm like, I'm not a full stack developer, but okay. Transparent iframes or transparent buttons. I'm like, okay, that might be a thing. It just reminds me of like wall hacking in video games. You're like, yeah, why would you ever make a texture transparent? Well, if you want to cheat. So that's the idea. I make this sensitive part of a site. And you can see here, this one is, I'm going to transfer funds, but I don't want the user to know that I'm on the page that's about to transfer funds. So this thing is made transparent. And then the malicious site puts up underneath that transparent iframe some content that says that is very enticing. So win big, and then click this thing to win. And aligns that click to win underneath the confirm button of the transparent iframe. And then the user clicks on what appears to be big winnings and ends up clicking on confirm this transfer instead. So that's ClickJacking in a nutshell. So how do we prevent this? Why is this not a big vulnerability anymore? The first thing was the X-frame options header, and this is a response header that the server that has the sensitive iframe to host will send back to clients. So if you're on the malicious site, you're going to try and render in an iframe the legitimate site's page, but in accessing the legitimate site is going to set this X-frame options header and say, is that allowed or not? Okay, so that's the idea. So the site can say, never load my content in an iframe. If the browser is trying to render an iframe and the iframe is going to my domain to deliver that page, I can tell the browser to disable it all. Just completely deny all iframes, and that's something that you can set for your site. The other thing, say you want to use iframes but only within your own site. You're going to render iframes of your own content on your own site. That's the same origin policy. Okay, so you can set that as an option. You can also specifically allow iframes from certain sites. So you can enumerate the sites that are allowed to render your content in an iframe on their site. And then the browser will be able to check, hey, I'm on Facebook.com trying to render an iframe that's actually from Instagram, and Instagram is telling me that Facebook.com is okay to deliver a frame with my content in it. So that's the allow from specific site. And you can check what a site's frame options are. So here you can connect up to Google on port 80 and say, okay, get me the top level page. And then what you would get back is a bunch of stuff, including the header, that says X-frame options, same origin. So Google has it set that the only iframes that can be rendered using its site are ones that come from its site. So I won't be able to, and this is your lab actually, you'll be creating some HTML files that say, oh, render Google in an iframe, and then your browser's going to be like, can't do that. Google told me I can't do that. Whereas if you render some of my sites, I'll let you do it, no problem. But I have nothing to lose, hopefully. The other way so one of the things about this X, so you'll see X in front of a bunch of HTTP headers. X means experimental. This means that they don't want to permanently encode this as the standard. And hopefully the X stuff gets deprecated, because that's what it's intended to do. And it's going to be deprecated with this content security policy header. So we talked about content security policy already. The idea of that header is to unify all of these different things, right? I shouldn't have a separate header for each of these individual countermeasures. I should just have one content policy, and then this is just one of those things. And the header directive that you would use is this thing called frame ancestors. That says which are the sites that can use my content in an iframe is frame ancestors. And it's very similar syntax to the other CSP headers. So content security policy, frame ancestors, and then you give it a list of sources that are okay to host your stuff in an iframe. Okay? So here is an example where maybe you're in example.org. And example.org has this content security policy, and it says any iframe that is delivered by a page from my site, which is the same origin, or any subdomain of my site, those are the places that are allowed to render my content in an iframe. Okay, and then you would just specify. You would whitelist, basically, the sites that are allowed to render your iframe content. Okay, so there's going to be a lot of time for labs and homework, because I gave you a bunch on Tuesday. So the labs and the homework, I'm going to have you do the first CSRF lab, so only one, just to get you an idea of how CSRF works. The first ClickJacking lab. And then I'm going to have you do a ClickJacking prevention lab that shows you how having different settings of X-frame options impacts your ability to render an iframe. So that is the code lab. And then for the homework, you're just going to do the CSRF lesson and just the first CSRF challenge. So I don't want to do too much in these two things just because they're pretty much squashed. At least bugs are squashed, but there's a lot more levels to this if you want to keep on going down the path. And this is something I should mention, like sort of forward reference your final project. You see a lot of levels on Portswigger. One of the final projects that you can do is to just do a whole bunch of them. And so if you like ClickJacking and CSRF stuff, then that would be an option for you to do. So with that, that's all I have for today. I'll let you get to work. Are there any questions? Okay, let me finish taking a